Hello, students. This is Mr. Lowry. This is the worksheet that we did today. So if you're in A cohort, this would be from 1028, and if you're in B cohort, it's 1029. In this assignment, we're going to look at standard form again, which we talked about earlier this week, and we're going to extend it a little bit, talk about horizontal and vertical lines. We also have a test coming up this week. So we're going to do a few review topics as well. So we're going to kind of use this assignment for a few different things, to finish talking about standard form, but to also get ready for our test. So the first problem here is very similar to what we did on our last assignment. We're just kind of using standard form in a real-world scenario. So recall that standard form looks like this: ax plus by equals c. It's really convenient when we have some scenario where we have two different variables and we want to kind of add them together to get a total. So in this case, we have Isaac shopping for refreshments for a school dance. He wants to buy some packages of cookies and some bags of chips. Cookies are $5 per package, chips are $3 per bag. Isaac has a budget of $75 for all the refreshments. So this idea, $75 for all, that's like a total. And so we know that we need to have equals 75 when we total up the cost of our snacks here. Some other quantities that we have are cookies, $5 per package, and chips, $3 per bag. What we don't know is how many cookies and how many chips, or how many packages of cookies and how many bags of chips that we need. So we need to assign those variables. So I would say that x is equal to number of cookie packages, and then y is equal to the number of chips packages or chips bags. Okay, so I don't know how many there are, but I do know how much they cost. So it's going to be $5 per package of cookies, and I need to multiply that by the number of packages I get. That's going to be the amount of money that I'm going to spend on just cookies. Now, if I add that to the cost for chips, it's going to be $3 per chip bag times the number of chip bags that I'm going to buy. So that is my standard form equation right there. 5x plus 3y equals 75. So notice it looks like this. Okay, so standard form. All right, if Isaac buys only cookies, how many packages can he buy? So only cookies, right, only x's, that means that y is going to be equal to 0. So 0 chips. If we substitute y is equal to 0 into our equation, we get 5x plus 3 times y, but y is 0, equals 75. So this is going to go away. We don't need that anymore. 3 times 0 is just 0. And I'm left with 5x equals 75. Okay, all I have to do now is to solve for x. I just got to divide both sides by 5, and that's going to come out to be x equals 15. And we're talking about packages of cookies. Okay, so that's the answer to part B. But one thing that we might want to keep in mind here is that x is 15 when y was 0, right? We set y to equal 0. So as a coordinate, this would look like 15 comma 0, 15 packages of cookies for 0 bags of chips. And that is going to be an x-intercept if we were to graph this guy. For part C, kind of a similar process, only this time we're going to buy only chips, which means the amount of cookies that we're going to buy is 0. The packages of cookies is 0. So $5 per package of cookies, but there's 0 of them, plus 3y equals 75. So again, the 5 times 0, we don't really need that part. We just have 3y equals 75, but we want to figure out what y is, how many packages, or how many bags of chips. So divide both sides by 3, and we get y equals 25, and that is bags of chips. All right, now again, we have our answer already, but if we think about this graphically, this represents a coordinate, right? We have 25 bags of chips, or y is 25, if x is 0, right? So we only have 25 bags of chips if we buy 0 packages of cookies. All right, so this is going to be our y-intercept. All right, so what we're going to do in this assignment is we're going to connect this idea to a graph. We want to be able to graph things in standard form. So this is a graph in standard form. Or excuse me, this is an equation in standard form. If we want to graph it, one of the ways we can do that is to find the x and y intercepts, right? We just did that. These questions here are basically asking us to find our x and y intercepts. Okay, now if we wanted to graph that, it doesn't ask us to do that in the question, but we could do something like that. So I'm going to use this little sheet of graph paper, and we could make a graph. Now I'm going to scale my axis by 5s here. So x represented the amount of cookie packages that we had, and y represented the amount of bags of chips that we had. So if I go like 5, 10, 15, 20, 25, like that kind of thing. And then over here, I'm going to go 5, 10, 15, 20, 25, 30, 35, right, that kind of thing. So I'm just going by 5s. The two coordinates that I have are 15, 0, so 15, 0 would be right here, and 0, 25, which would be here. Okay, so if I wanted to graph this scenario, I already have 2 points. What I could do is I could just connect these guys with a line, and that would be a pretty decent graph. Now last time we talked about how we probably don't want a line, we actually want several different points, and we don't care about the negatives and the negatives here. The main idea I wanted to get you thinking about is that if we want to graph an equation in standard form, one of the easiest ways to do that is to find the x and y intercepts, which is what we did here. All right, so let's connect that to what we got going down here towards the bottom of our assignment, or our page here. Okay, we're going to take a look at a couple of these different ones. I'm going to start with number 4 because I think this one's a little bit harder than number 2. But the idea here is if we want to sketch the graph of each line, what we're going to do is find x and y intercepts. Okay, this is going to be the method that we're going to use to graph, finding the x and y intercepts. So if we look at number 4 as an example, what I'll do here is I'm going to make a table, a little tiny table, with an x here and a y here. And I want to find the x and y intercepts. So what I do is I make x 0, and when I find y, that's going to give me a y intercept. And I also am going to make y 0. So 2 different coordinates here, but both of them have zeros. One has an x for 0, and one has a y for 0. And I'm going to figure out the rest of this point, because I only have half of it right now. So for the first guy, x is 0. Let's see what happens when x is equal to 0. We're going to take this equation here, it's in standard form, and we're going to do 2 times 0, because we made x 0, right? X is 0, so x is 0, x is 0. 2 times 0 minus 3 times y equals 6. Okay, well, just like we did in the previous problem, this is going to go away, and I have negative 3y equals 6. All I have to do now is just try to get y by itself, and I can do that by dividing both sides by negative 3. Okay, so when I do that, 6 divided by negative 3 is negative 2, so y equals negative 2. When x is 0, y is equal to negative 2. Okay, so that's a coordinate. That's the y-intercept right there. So x is 0, that means I'm going 0 left or right, but I'm going to go down 2. Okay, so there's 1 point on my graph. All right, now I'm going to do the same thing again, but this time I'm going to make y 0. So I'm going to take my equation, and I'm going to make y equal to 0 and see what happens. So 2x minus 3 times 0 equals 6, right? Y is 0 now. So 2x, this part goes away. Minus 3, 0, we don't need that. 2x equals 6. Divide both sides by 2 to get x by itself, and x is going to be equal to 3. Okay, now x isn't always equal to 3. It's only equal to 3 when y was equal to 0. All right, so this is an x-intercept now. It's the point 3, 0. So x is 3. That means you go 3 to the right. Y is 0. That's 0 up or down. And there's my other coordinate right there. Okay, so once I have those 2 coordinates, I can kind of connect my graph here. And then I got a pretty good graph. Okay. Now, the difference between this one and the ones we made the other day when we were talking about standard form, is this goes infinitely in either direction, so we want to have arrows and stuff. We want to keep going. We do care about the negative stuff. We also are going to have a line instead of just different points. All right. So to graph an equation in standard form, what you can do is you can make a little table where you find the x and y intercepts. Again, this was the y-intercept here, and this is the x-intercept here. Okay? That will give you 2 points that you can use to make your graph. All right. Let's do one more of those really quick. We'll do number 5, because 5 has something that kind of funky that happens. All right, so same thing. We're going to set it up the same way. All right, x and y. Okay. Now I'm going to put a 0 here and a 0 here. So these are going to be 2 different coordinates. One of them is going to have an x of 0. One of them is going to have a y of 0. All right, from there, I just substitute into my equation, and then I see what I get. So for the first one, x is equal to 0. That will give me 2 times 0 minus 3 times y equals 9. Okay, 2 times 0 is 0. So negative 3y is equal to 9. Okay, I want to get y by itself, so divide both sides by negative 3, and I get y equals negative 3. Okay, so one of my points is 0, negative 3. Right? 0, negative 3 would be 0 to the left or right, and then 3 down. So that's my y-intercept. All right, now I can do this process again, except this time I'm going to make the y equal to 0. So this point will be where the y is 0, so I'm going to put a 0 right there. So we're going to have 2 times x minus 3 times 0 equals 9. Remember, this part we don't need anymore. I just have 2x equal 9. And now I divide both sides by 2. Okay, now usually we like simplified improper fractions, which this is, 9 over 2. But if we want to graph, we might want to know where this is on the number line or on the graph. So if we actually do 9 divided by 2 in our calculator, we get 4.5. So decimals are kind of helpful here for graphing. So x is 4.5, right? So that's a coordinate. This is my x-intercept. So I want to go on my x-axis. 4.5 would be halfway in between 4 and 5. So 1, 2, 3, 4. Here's 4, here's 5. 4.5 or 4.5 would be right in the middle. And then I go up 0. Okay. So that is those are my 2 points. And then I can just use those 2 points, connect the dots here, right, and then I got a pretty decent graph. Okay, so that is how you graph an equation that's in standard form. You want to find the x and y intercepts. It's kind of like saying, well, what if we had 0 packages of cookies? How many chips would we need? What if we have 0 bags of chips? How many packages of cookies would we need? We find those 2 extremes, and then we connect the dots. All right, we're going to skip down a little bit and talk about horizontal and vertical lines. So we're looking at 8 and 9. Okay, so notice that on these guys, we only have one variable, right? This is y equals 5, this is x equals 4, which is a little bit strange. If we think about making a table, we could make a table here where all the y coordinates are equal to 5. So I'm going to make a table, x, y, right? We probably won't do this every time, but just to kind of get an idea what this looks like, we'll make a table. So y is equal to 5. That means for any point possible, y is always equal to 5. We just set y at 5. So 5, 5, 5, we have a bunch of 5s down here, okay? Now there's no x coordinate in here, and the x coordinate, if we chose it, it wouldn't affect y. Y is always 5 no matter what. So we can just pick some random x's like 1 or 0 or negative 2 or 3 or something like that. And we can, have some coordinates here. So the coordinate 1, 5, x is 1, that's 1 to the right, and then y is 5, so 5 up. So there's 1, 5. Okay, 0, 5 is right here. Negative 2, 5 would be 2 to the left and then 5 up. And then 3, 5 would be 3 to the right and 5 up. Okay, so notice that because the y is always 5, these coordinates are always at the same height. And so what I'm going to get is a horizontal line. Okay? So when you have y equals a number, we're just going to call that, like, let's say y equals b, and b is any number. This is going to be a horizontal line or a flat line. Okay. Now, sometimes students get confused on this because you look at this and you're like, hey, there's the y-axis, right? The y-axis goes this way. So shouldn't y equals 5 go the same way as the y-axis? And it actually doesn't, and this is why. If you have y is always equal to 5, then all your points are the same height, which makes a horizontal line. So instead of thinking about, when you look at the variable, you see the variable there, instead of thinking about what axis does it look like, think about what axis does it cross. Okay? So when you see that y there, you know it crosses the y-axis. And it crosses the y-axis at 5. Okay? So any y equals number equation, if there's not an x, it's just y equals number, is going to be a horizontal line. It's going to cross the y-axis at that height. Okay, so if we look down here at number 10, which is also a y equals, okay, you look at this thing and you're like, okay, y variable, that means it crosses the y-axis. Okay, so it crosses the y-axis and it crosses it at -2, so right here. Okay. So there's y equals -2. It's going to cross the y-axis right at -2. So you don't have to make a table every time. You just know that y equals number is horizontal. It crosses the y-axis. It crosses this guy. It hits the y-axis at -2. Okay, so horizontal line that crosses the y-axis at 5, horizontal line that crosses the y-axis at -2. Now, if you wanted to make a table for this, you totally can do that. If you ever get stuck, right, x and y, you just know the y is always -2 no matter what. So you could pick like 1 or 4 or -3. Doesn't matter what you pick for x. The point 1, -2 is right here. 4, -2 is here, 4 to the right and 2 down. -3, -2 is 3 to the left and 2 down. Right? They're always, the points are always -2 high, which creates that horizontal line. Okay. Now for the x ones, it's kind of the opposite idea. So when you look at the variable and it's just x equals a number, this is going to cross the x-axis at 4. Okay. If you want to make a table, you can definitely do that. Okay, we got x and y. X is always equal to 4 no matter what. So every x coordinate is always going to be 4, and then I can just pick some random points for y, random coordinates for y. Let's see what this looks like. So 4, 1 is 4 to the right and then 1 up. 4, 2 is 4 to the right and 2 up. 4, -1 is 4 to the right and then 1 down. 4, 3 is 4 to the right and then 3 up. So altogether, we're going to get this vertical line. Okay. So if you have something like x equals a, and a is just some random number, this is going to be a vertical line. Okay. If you look at it and you say, okay, x equals 4, it crosses the x-axis. Here's the x-axis. It crosses the x-axis at 4. So again, this is kind of confusing because students are like, hold on, the x-axis goes this way. So shouldn't x equal 4 go the same way as the axis? And it actually doesn't. It crosses the x-axis at 4. Right? And you can see that if you make a graph and you make all the x's 4, you can see how it's going to cross the x-axis at 4. Okay, now for 11, same idea. We don't need to make a new table. We could if we wanted to, but the idea is you see this x equals number, and you're like, okay, this is the axis that it crosses x-axis. And it specifically crosses at 2. Okay, so if you go down here and say, okay, here's the x-axis. It crosses the x-axis at 2. There you go. It's also a vertical line. All lines that have x equals a number, or all equations that have x equals a number, are going to be vertical lines. All equations that have y equals a number are going to be horizontal lines. Okay, let's look at a couple more here. All right, now these ones we're going to do the opposite. We want to write the equation. We also want to find the slope. Okay, so first thing I would do is think to myself, what axis does it cross? So I look at this guy and I'm like, okay, this crosses the y-axis. That means it's going to be a y equals equation. It crosses at 3. That means it's y equals 3. That's my equation. Okay, now, if we were confused and we didn't know, we could always pick some points on this line and figure out what's going on here. So let's pick 3 points on the line and then write the coordinates down. Okay, these coordinates are 1, 3, 2, 3, and 4, 3, right? 1, 3, 2, 3, 4, 3. And you'll notice that what's in common is the y is always 3. The x changes, but the y is always 3. So y equals 3 is your equation. Okay, now for the slope, we already talked about that last week. Okay, the slope of a horizontal line is always going to be 0. If you look at rise and run, or change in y over change in x, let's take these 2 points for example. The rise here is 0. The run is 2. So rise over run is 0 over 2, or just 0. Okay, so the slope of a horizontal line is always going to be 0. Okay, so those are 2 different questions. We want to find the equation. That's the equation. We also want to find the slope. The slope is 0. Okay, horizontal lines have 0 slope. All right, so if we look at 15, similar idea, right? It's a horizontal line, and it crosses the y-axis. So if it crosses the y-axis, it's going to be y equals. Okay, it crosses at -4, so y equals -4. That's your equation. So what axis does it cross? Where does it cross it? That's your equation for horizontals. Okay, the slope, again, it's 0. It's a horizontal line. So that's kind of one of the things we just kind of memorize. Slope of a horizontal, the slope of a horizontal line is 0. For this guy here, this is crossing a different axis, right? Here's the x-axis. This actually crosses the x-axis. So it's going to be x equals -3. All right, now again, students get confused because they say, well, the x-axis goes this way and the y-axis goes this way. So when they see the y-axis and they see that this is going in the same direction, they're like, oh yeah, it's going to be y equals. But remember, vertical lines are x equals. Okay, so x equals -3. Not what axis does it look like, what axis does it cross? This crosses the x-axis at -3. Okay. Vertical lines have a slope that's undefined. We talked about that last week. Undefined slope for a vertical line. Okay. Now, if we wanted to just look at this in more detail, and we picked a couple points here, like let's say these 2 points, and we looked at what those points were, this is the point -3, 1, and -3, 3. So notice that x is -3. In fact, any point on this line, this is -3, -4. X is always going to be equal to -3. So that's why the equation is x equals -3. If we look at rise over run, the rise here is 2, the run is 0, and if you try to do 2 divided by 0, your calculator is going to shoot out an error. It's going to say, you know, math error or something. So 2 divided by 0 you can't do. It's undefined. It's not a number. That's why the slope is undefined. Okay, here on 14, you got a vertical line, and it's crossing the x-axis. So because it crosses the x-axis, x equals, it crosses at 2. Okay, so x equals 2. And we know it's a vertical line, goes straight up and down, so the slope is undefined. All right, so that's how we deal with horizontal and vertical lines. That's going to take a little bit of memorization for you. So I would, practice, and you can even make yourself some flashcards or whatever. But horizontal lines look like y equals a number. They cross the y-axis. Their slope is 0. Vertical lines look like x equals a number. They cross the x-axis. Their slope is undefined. Okay, there's a couple more questions on the back here that are review to help you kind of get ready for your test, questions that maybe we haven't looked at in a while or things that I think we maybe need a little more help on. I'm going to do this in a different video because this video is already too long, but when if you wanted some help on these problems, you can tune back in and check those out.